Okay, calculus, this is 5.1 video lesson number 3. Only 3 boxes here, but we're just going to get a lot of practice in terms of trying to figure out how to get good at integration, okay? So I'm going to do a couple of examples for you, and then I'm going to have some some U-tries for you guys to try. Okay, here we go. In examples 1, we're going to rewrite the expression before we do integration. So you can see on the left-hand side for part A, I have the integral of 1 over x squared dx. I'm going to choose to rewrite this as the integral of x to the negative 2 dx. That is then going to allow me to use the simple rule number 5 that we talked about in the first or second video, the power rule. So this is going to be x to the negative 2 plus a 1 over a negative 2 plus a 1, which of course is going to give me x to the negative 1 over negative 1 plus c. So I'm going to clean this up and write it as the negative of 1 over x plus c. And this is how we want to rewrite this thing. Okay, let's try part B. Again, I am going to rewrite this before I do any calculus. I'm going to rewrite this as the integral of 1/2 x to the negative 4th dx. Notice how the 1/2 is still, it has nothing to do with the exponent on the 4. So this is a constant. I'm going to pull this through. So this is going to be 1/2 the integral of x to the negative 4 dx. That's going to be 1/2 times x to the negative 4 plus 1 over negative 4 plus 1, which is then going to give me 1/2 x to the negative 3 over negative 3, and then a plus c. So all I have left to do is clean this business up here. So this is going to be negative 1/6, and then x to the positive 3rd on the bottom, and then a plus c in the back end. So hopefully you see the algebra that we did to get that one correct. Okay, so the 1/2 times the negative 3, that's the negative 1/6. The x to the negative 3 goes to the denominator, becomes a positive x cubed plus c. Hopefully that's not so bad, okay? Let's try examples C and D here. So before we do any calculus, again, I'm going to rewrite this as the integral of x to the 1/2 dx. And then I'm just going to use the power rule. That's going to give me x to the 1/2. Oh, my pen's messing up here. Whoa. 1/2 plus 1 over a 1/2 plus a 1 plus a c. Then just going to clean this up. That's x to the 3/2 divided by 3/2 plus c. But we don't leave it like that. We write it as 2/3 x to the 3/2 plus c. Hopefully you see that when I'm dividing by 3/2, it's the same thing as multiplying by 2/3. Okay, and then lastly here, before I do any calculus, I'm going to raise the entire denominator to a power of 4. So this is going to give me the integral of 1 over 2 to the 4th is 16, and then x to the 4th. Then I'm going to rewrite that as 1/16 times the integral of x to the negative 4 dx. So hopefully you guys are seeing this constant being pulled through. This is going to be 1/16 x to the negative 3 over negative 3 plus c, which is then is going to give me negative 1 over 48 x cubed plus c. So this is the level that we need to be at this moment in time. I will give you a second to copy all those down that you need. There's all 4 of them if you need them before we move on. Okay, box number 2. Let's talk about 2 classic mistakes that calculus students make in this section. Let's say they have the integral of x times 3 minus 4x squared all squared. You are not allowed to break up this into 2 separate integrals that are still being multiplied together. Do not separate the product. Instead, you want to multiply this out first. So take this binomial, square it, and then multiply everything by x. Do not do that classic mistake. Here's the other classic mistake that students make. If I have a square or the integral of x minus 1 over rad x, of course dx in there, we are not allowed to split up the integral on a top and a bottom. Do not separate the numerator and the denominator. Instead, break up the fraction like this. And then, of course, we can change that into the subtraction of two separate integrals. That is a rule that we are allowed to follow, 1 over rad x, but not this rule up above. So don't do that. So those are two classic mistakes that I definitely want to make sure that you are aware of. Okay, here is a you try. I want you to try this problem on your own. Select the answer that you think it is. If you get it right, I will be very proud of you. Ready, set, go. Okay, hopefully you got the right answer. Here's the deal. The 1/3 is going to come out because it's a constant. I'm going to rewrite my x to the 5th in the denominator as an x to the -5th. I'm going to use a simple power rule and come up with -5 plus 1, which is the -4. Multiply everything together and rewrite it as -1 over 12x to the 4th plus c. Okay, here is your next you try, the integral of the quantity 3x squared dx. Okay, hopefully you got the right answer again for this one. The solution is we're going to take the integral of 9x squared dx. I'm going to raise each of these to a power of 2. I'm going to pull my 9 through my integral since that's just a constant. I'm left with x squared. That goes to x cubed over 3 times a 9 gives me 3x cubed plus c. Okay, and here is your last one. The integral of x times the product of x minus 3 squared dx. Okay, hopefully you got the right answer on this one. Here's the solution. First thing you're going to want to do is you're going to want to square this binomial. So x minus 3 all squared, we should all know that that's going to be x squared minus 6x plus 9. Then multiply that by your x value to get x cubed minus 6x squared plus 9x all dx. Then break up each integral through sums or addition and pull your constants through. That gets you to x cubed minus a 6 integral of x squared plus a 9 integral of x. And then just apply the simple power rule, and you end up with x to the 4th over 4 minus 2x cubed plus 9 halves x squared plus c. All right, you guys, I hope this helps, and we'll practice more in class on Monday or whenever I see you next. All right, see you.